Hello, and we are live. I hope you're all doing well. Thank you all for coming. Tonight's going to be another special. We got someone coming to present their globe evidence. Sorry, my phone doesn't want to. Okay, so it's good to see you guys. Thank you all for coming in. I'm going to still send him the link to see, to let him join. But I said I would do it in about another 5 to 10 minutes. Because the power is going off at 11 again. So I just thought, let's get the house in order before we start the show properly. And as he presents, because I don't know how long he's going to present for, but it's good to see you all here. Thank you all for coming again. Really appreciate it. Now, why can't I get my screen? Okay. So I got the poll up, 68 votes. Polaris is for FE, which is actually yes, because it's based on elevation angles, but we'll get into that. Yes, 32%, no, 67%. Obviously, a lot of Globers in here tonight. Good to see you all. And I have no idea why I cannot scroll up on my chat. I'm trying to. Okay, I'll chat up here. I'll scroll up on here. So, hey, good to see you, PJ Cruikshank, Jess Palmer, Moxie, Glober Sunder, Duper Poons, Moomin Rider, thank you for coming. Jimmy J, Richard, trying not to be a dick. Thank you for coming. Drijic, who else? I saw more people in here. Michael Khan, thank you for being here. Wiz 777, Alan Norstrand, QNF, good to see you, mate. Thank you for coming. Gematria Wombat, hey. Who else? I think that is everybody I can see in chat. And Dustin Bones too, and Arwen. And then Face Reality, thank you for coming. And William Brackley. Yeah, so the guy is going to be presenting what he calls as a Polaris versus Globe evidence. So I think he's probably set up a kind of a model where it's, how can I put it? If it's going to be showing Polaris with geometry probably on a globe and Polaris with geometry on a flat Earth. So we'll see what he presents. I have no idea what he's going to present yet, but that's what he's going to do. His name is MediaDon, I think his name is. So let's see what he's going to present. I just did send now to him. I'm excited because it's always good to see when the Globers come and present their so-called globe evidence, because it usually just shows measured flat. Hey, Tom, good to see you. Thank you for coming. Glad you can make it. If you guys haven't already, please just hit that like button and share the show, because the more people it gets shared to, the better. Oh, yeah. If you guys don't know, Dave McKeegan actually did a reply to me on the up and down thing. Little does he know that he actually just validated me. So I'm glad it worked to get his attention, because the guy is kind of scared to talk to me for some odd reason. I'm not sure why. So hopefully he'll come in soon. Cool. He says he's going to join now. And then I got McToon as well, that took the insert of Andrew Thompson when he came to present the triangles. He literally just made a claim in the beginning of the video, say, he did such a great job presenting the globe. It's a globe, it's proof. And then he shows the whole presentation from Andrew, and then he ends it there. He didn't even give an argument for it, nothing. Because he knows if he's going to actually give an argument based on it, he's going to be shown to be fool, because the whole presentation showed it measured flat for over 4,000 kilometers. So yeah, that's quite interesting. I did send him the link. He says he's going to join now, so we'll see what he's going to present. Hopefully he's going to link soon. Hope you guys are always doing well. I'm doing much better. As you can see, the swelling has gone down a lot. I don't look like a Simpson anymore, so that's a good thing. I'm expecting tonight to go smoothly, I hope. Don't know where he is yet. Yeah, it looks much better. I can actually talk normally now. Only thing I must say, I do miss coffee, because I've been drinking with antibiotics for the last 3 days. been eating dry bread and drinking water. So I'm practically fasting, guys. But it is helping. Yeah. So I think it was PJ. Is it tonight or tomorrow? I think he said it's his son's 15th birthday. So shout out to PJ's son for your 15th birthday tonight or tomorrow. I'm not sure yet, but happy birthday, mate. And yeah, we have MediaDon. Hey, mate, how are you doing? Good to see you.
Hey, can you hear me?
Yes, can hear you perfect, mate.
Awesome.
So, you say you got something to present to us?
Yeah, I have a Word document.
Yeah,
Yeah.
awesome. Do you maybe want to present yourself quickly, say who you are and whatever before we start?
Okay, so my name is actually Solomon. I'm from Kenya. So I actually hope you can understand what I'm saying because I'm not a native English speaker. So yeah,
Definitely no
and
stress,
in
mate.
quotes, and also in quotes, I'm a globie.
Obviously. But yeah, it's good to see another African in here.
Yeah,
Kenya gets quite hot as well.
exactly.
I just have one question for you though. Can you jump very high?
I can't. I'm not that athletic actually.
But it's good to see you on. Thank you for coming. I really, really appreciate it. You would be able to share screen. That's why I decided let's use StreamYard.
Okay, yeah.
Awesome. Yeah, but like I said, guys, I always appreciate when you guys come and present. It's really good to see people presenting things and actually not just hiding in chat. So that's a good thing. So I really admire you for that, and I give you much respect.
Awesome. Thanks, man.
And everybody in chat says you're speaking well. That's cool.
So I can continue sharing my screen, yeah?
Yeah, you can share screen. Then I'll just not showing anything yet. You because I think you have to press present at the bottom and then press share screen.
Okay.
Yeah, Dustin Bones hiding in chat just like you. Okay, add to stream. There we go. Okay, I've got it. Hiding in chat just like you might. I think if you're going to talk and present, I'm going to do like Andrew. I'm not going to talk. Okay, so I'll let you go through your whole presentation, everything, and then we can rebut.
Okay,
Fine?
no problem. Okay, no problem. Okay, so actually, so my presentation is it's not that long actually. So it's just about how Polaris will work on flat Earth and how it will work on a globe Earth. Just that. So okay, let me just start. So the first thing I want to is to just define some of the basics. So like what is perspective? So we'll use perspective on a flat surface. So let's use, for example, a tree on a flat surface. So we can agree. I hope we can agree on this that angle will reduce or compress with increase in distance to a point where an increase in distance doesn't have any further drop in angle. Okay, also called vanishing point. So actually, so that's why I have this is just like an object of a this is a tree. I don't know if you can see my mouse or not.
Yeah, I can see your mouse. Yeah.
Awesome, great. So you can see now this is the tree. So you can see the with increase in distance, you'll notice that the angles will keep on decreasing up to a point where it won't decrease, it won't decrease further. So another example is using a light pole. So actually, I used this is an image I got from you, Flatzoid, actually. Yeah.
Oh yeah,
So
as well. I can see. Yeah.
yeah. So the same thing with a light pole. So you can notice when you're close, for example, when the angle will drop will be larger near the bridge, but with an increase in distance, the angle drop will continue to be small up to a vanishing point, where increase in distance won't cause any further horizontal reduction of the angle, aka the vanishing point. I hope that is okay.
Okay. Yeah. So you're saying it's
Yeah,
compressing into the distances. It's seeming to become closer together as it falls away.
Exactly. Like the further you go, the more compression it happens.
Yeah.
Okay. So let us now draw like a perspective angle drop with distance. So perspective angle drop versus distance. For example, of the tree shown above. So this is called an exponential decay curve. So you'll see like with increase in distance, you'll notice it's an exponential decay curve. It's not linear. And the reason why it's exponential is because with the increase in distance, the angle drop will continue to reduce up to a vanishing point where any further increase in distance won't have any extra reduction in angle. So that is not a linear curve. That is exponential decay curve. So that's that. So let me tie it back to Polaris observation. So this is how what we observe with Polaris. So the degree drop of Polaris with distance. So you'll notice there's a problem. Why I'm saying Polaris doesn't follow the law of perspective, because you'll notice it is constant. It's a linear curve because for example, we've seen perspective. For perspective, increase in distance will lead to reduction in angle drop. But for Polaris, it's actually not, it doesn't work like that. For Polaris, an increase in distance will lead to a constant reduction in angle drop. So this is actually, I got this curve, actually I got this diagram from you, Fladzo, so you can't say I made it up myself. So you'll notice as Flash showed above that there's a linear relationship between angle drop with distance. For every 600 nautical miles, a drop of 10 degrees is observed. This can be represented by a graph. And so this is increase in distance, and this is angle drop. It's a linear curve. It's not an exponential decay curve. It's a linear curve. So, and this is what I've said. Polaris sky drop is constant with increase in distance from the North Pole. So let us try and look at the two different graphs at the same time. So Polaris angle drop as observed versus perspective on a flat surface. So perspective on a flat surface, as you've seen, is an exponential decay curve. But Polaris is a linear curve. So it doesn't follow the laws of perspective. Okay, so let us continue. They have different curves because Polaris doesn't follow laws of perspective. Perspective say that increase in distance should lead to a smaller and smaller angle drop up to a vanishing point. But for Polaris, increase in distance lead to a constant angle drop. Just that debunks perspective. So this is the question I have to flat earthers. The question I have to ask is how can you explain how can this be possible on a flat earth where something goes against law of perspective? So I already know some of they only actually I've really thought through, and I think the only two ways you can try to explain this on a flat earth. You can either say it's perspective, and we've seen it doesn't follow the laws of perspective because perspective is an exponential decay curve, but Polaris is a linear curve. So the remaining, I think the remaining I think the other another way flat earthers can use will be to say it is caused by refraction. So that is just about perspective. Now let us go to the second point. Actually, three main points. So I'm done with perspective. Now let's go to the second point, which is you cannot explain Polaris' apparent position on a flat Earth. So this is what I'm saying. You can notice another weird thing happening with Polaris on a flat Earth. At the ground position, when you draw the correct angles, you notice that they don't intersect at a single point. This is from you, Fladzo. So this is not even me who created this. You can see Polaris or to scale on a flat Earth, the angle will intersect at different positions. So this is my question. So why is it not intersecting at a specific point? And as I told you, you can only explain it using two ways, either perspective or using refraction. And we've seen Polaris goes against perspective. So you can't use perspective to explain Polaris. Now, it is the only remaining thing is called refraction. And I'll go through that. One explanation I can see flat earthers try to use is due to atmospheric refraction. The problem with this argument is that it makes it worse for them, as refraction can't explain it, as can be shown. I can show you down there. Light going through atmosphere will bend more and more towards normal. As the lower you go through atmosphere, the denser the air will be, thus increasing the refractive index. So there's I have this this is how refraction works actually. And I know flat earthers don't want to admit we have refraction, but you have to admit you have refraction because you can't explain it any other way. So this is how refraction works on the atmosphere. So because the atmosphere, you have to agree that the higher you go, the less dense the air is, and the lower you are, at the lower altitudes, air is much denser. And I don't know if you guys totally understand how refraction works. Refraction is just change of speed of light based on the medium it goes through. Light, when light is going through vacuum, it is going at the fastest speed. But when it comes into the atmosphere, it now gets refracted. And this is exactly how it happens. So refraction on our atmosphere, it always makes things apparent position to be higher than their actual position, because up on top is a less dense material, and in the bottom it is a higher dense material. So it will always, so a higher dense material will always have a more refractive index, and that's why it will bend the light to normal. So I hope you've gotten that. So thus, any light that comes at an angle to a person will make the object appear to be higher than they actually are. This creates an even bigger problem with Polaris on flat Earth. So you are trying to explain why the points don't intersect at one position. We've just taken an example of a 30 degree, of this line at 30 degrees. Standing at 30 degree latitude, you can see the apparent position. This is, if you're trying to assume, you're using now refraction to explain why the apparent position is not the same as the actual position. So you can see apparent position, for it to work, for refraction to work, to explain why the Polaris actual position does not show exactly where it should be. This is how you need it to be. So like, for example, let us say this is where Polaris is. So the light comes, then it gets refracted to this person. But this is not how refraction works on our atmosphere. So this is the apparent position, this is the actual position. So you can notice light is bending away from normal, which isn't what we see in atmospheric refraction. So this is exactly what we see in atmospheric refraction, how refraction should actually work on our atmosphere. So the apparent position is always higher than the actual position because of exactly what I told you. Less dense material on the top of the top of atmosphere, and the bottom there's higher, there's more pressure, and there's also more dense. So light will bend fast, we'll have a more refractive index at the bottom. So this is exactly how it should work. So if this is the apparent position for this person at 30 degrees, if you are trying to say refraction, that will mean the actual position should be even lower. And that is a big problem, because there's no way you can explain on a flat earth why why the different light, you can't model the observation of Polaris on a flat surface, because you cannot explain it using perspective, because it goes against laws of perspective. And using refraction, it actually makes it worse, because instead of it going upwards to 90 where the actual position is, it actually drops the actual. So you cannot explain. So this is exactly what I'm trying to tell you guys. You see why, you see the light is showing differently at different latitudes. When you draw a line, it doesn't intersect at a specific place, and you cannot explain that using both perspective, and you cannot explain that using refraction. So this is another thing. So this is now trying to just model Polaris on a flat Earth. This is just using now perspective, because the main reason why I did this actually is because I know Fladzoid, you are really, you are really obsessed with perspective, because everything you're saying is because of perspective, because of perspective. Now let us try and model Polaris on flat Earth using perspective. So since Polaris is at 0 degrees at equator, this forces Polaris to be very close to the ground at North Pole, or else the angles won't be able to drop fast enough with perspective. So this is exactly what I'm saying. For Polaris to be at 0 degrees, so I hope you know that Polaris is at 0 degrees at the equator, and at one degree latitude is 1 degree, and so on and so on and so forth. So for Polaris to be at 0 degrees at the equator, it has to force the Polaris to be very low above the North Pole, or when you use perspective, the angles won't be able to drop enough to 0. So Polaris has to be very low. So this poses further issues for flat Earth, since this will mean that the angles from, you can even see I've tried to show here, there's 1800 nautical miles. When you put Polaris to be so low, so that you are trying to force Polaris to have a 0 degree latitude at equator, you'll notice at 1800 nautical miles, you are getting almost 9 degrees, 9 degrees, and not the high 60 degrees we observe in reality for Polaris to drop from 0 to equator, from 0 degrees at the equator. So actually, and another funny thing is, I tried to make Polaris to be at 0 degrees. I couldn't find a way. So even this is, you can even see there's an angle here. It's not 0 degrees. So I said, and if Polaris is very high on flat Earth, it creates another problem, as the angles won't drop fast enough to reach 20 degrees, 10 degrees, 0 degrees, etc., as observed in reality. You can see if you say Polaris is close, it distorts some of these angles for some of these, like for 2400, it start compressing too early, and that is not exactly what we see in reality. And when you put Polaris to be too high, you can't reach you can't reach 20 degrees, you can't reach 0 degrees. So it's impossible on a flat Earth to get Polaris to be 0 degrees at the equator. This is considering if Polaris, you say Polaris is very high. So basically, this is my conclusion to all what I'm saying. It is impossible to model Polaris on a flat Earth, since it goes against law of perspective and refraction. No matter how much you try to model it, it will always introduce further issues, and there's no way to have Polaris model that 100% works on a flat Earth. So, okay, let me now show you. You see, you can now see how complicated Polaris is on a flat Earth, because it can't work. But on a globe, it's so simple. You can see Polaris on a globe is explained by two main things. Polaris is far distant star, that's its light rays reaches Earth in parallel. Another point is Polaris location is directly above Earth's axial tilt, so it won't move during Earth's rotation. So I have something here. This is just like a National Geographic to prove to my point. Earth axis points towards a star called Polaris. Which gets its name because it's almost directly above the North Pole. And actually, and you can even see Polaris will not always be the North Star. However, the Earth's axis is slowly wobbling away from Polaris. And you'll actually notice it's now 1 degree off from Polaris, because Polaris want to be the North Star forever. Any star that is above our axial tilt is our North Star, and Polaris is our North Star. And this is how you explain Polaris on a flat Earth. It's so simple. The light comes at a 90 degree, or at parallel, at all over the globe. At 90 degree, you can see it's 90 degrees, easy. When you are at 50, you just calculate this and you can see it 50 degrees. When you are at equator, it's 0. When you are past the southern pole, you can't see Polaris because it's now blocked by the globe. But the funny thing with flat earthers, it is always funny that light in flat Earth, suddenly you are seeing light, then suddenly at equator, boom, you can't even see it anymore. So you cannot explain Polaris basically on a flat Earth, but it's so easy to explain it on a global. So you can. So that is actually my presentation.
Thank you very much. I really appreciate it. A lot of begging the questions in there. If you want, we can start with topic one, that I can explain to you why you are wrong that you say
No
perspective does
problem.
not.
No
But
problem.
I really appreciate you. Thank you for the presentation. I think it was nice and concise and easy to understand.
Yeah.
Yeah, appreciate it again. Okay. First, I want you making a claim perspective. Polaris doesn't fall under perspective. Can you show me one instance in reality where perspective is not based in three-dimensional observations?
Pardon. Perspective is not based on 3 dimension.
When we look at things in our three-dimensional observation, it's perspective based, correct? Everything you see falls under perspective.
Exactly. Everything on Earth we see is based on perspective. Yeah.
Right. So how can you claim Polaris is not perspective based?
It's not perspective based because we can map what we observe on a physical Earth. So this is exactly what I'm saying. Uh, so let us take an example of any object on Earth. This is exactly, so this is like a tree or a hill, anything. You can see, you can easily even model a tree on a flat surface. And then using that, you can easily see that it has an exponential decay curve. And that is what happens to everything that is using perspective. It has to have an exponential decay
And
curve.
that's orthographic, correct? Orthographic
Yeah,
diagram,
yeah, this is orthographic, yeah.
which is two-dimensional, correct?
Definitely, yeah.
And perspective is three-dimensional.
No. Perspective can be shown orthographically in 2 dimension.
Okay, show me where the convergence is there, please.
So this is exactly what I'm saying. So if we continue to draw lines, for example, we continue to draw different angles, it will follow this curve. This is what I'm calling exponential decay curve. You'll notice that, and this is actually in everything, even this one you can even see it starts, the drop is fast, then it continues to slow down, and that is because of something of perspective. Everything follows an exponential decay curve, but for Polaris it doesn't follow decay curve. If we try to plot Polaris again for degree drop versus distance, this is exactly it becomes a linear curve. And actually, I'll also say that even you, Flazoid, you have even a whole chapter talking about the linear constants of Polaris. Exactly. Actually, it's true. You even have a chapter called linear curve or linear perspective. I've forgotten the exact term. And do you know what linear?
You know why it's considered linear, though?
Do you know what a linear curve is?
Yes, X and Y, but do you know why it's considered linear, though?
Exactly, I know why it's considered linear, because a linear curve it follows a constant. As a change
So
in something, you look for a change in.
if you go measure Polaris at 70 degrees, you're measuring it at 70 degrees, correct?
Exactly.
Okay, you go measure it at 40 degrees, you're measuring it at 40 degrees.
Exactly.
Is that the actual position or just the apparent altitude position?
Exactly what I was talking about. If you're talking about apparent position, what causes the apparence in a flat surface? What causes the apparence? Is because of refraction. Perspective doesn't cause apparence. It does
Yes,
not
it
cause
does.
apparent.
Those
It
light
doesn't.
bulbs you showed,
Do you know what apparent? Do you know what apparent means? Apparent
yes,
means it's not there.
apparent position. It's the optical apparent position.
Basically, apparent position is basically saying it's like an illusion. It's like it's not there, but it's supposed to be there.
No,
And
you can
what
see
causes
it. That
what
apparent
causes
means you can literally see it. It's apparently there. That's what apparent means. It's apparently there. It's apparent
that
to
is
see. That's what
actually
apparently means.
actually I have another presentation I need to take you through, because I noticed you couldn't understand some of these things. Honestly,
No,
like
I understand 100%. That's why I was laughing. Sorry. I still want you to show me where you took convergence into orthographic view, because McToon had exactly the same issue here. Claiming orthographic view is perspective based. Orthographic view is only two-dimensional. Perspective is three-dimensional. So you need to place all those three dimensions in a two-dimensional diagram.
Perspective is three-dimensional, but you can model it in 2D.
So which
This is exactly what I'm saying. You
Which,
can easily this is 2D perspective
which
in 2D.
dimension are you going to ignore then? Tell me which dimension you're ignoring to make it orthographic.
I'm not ignoring anything. I'm just representing. It's so simple. Like this, you can easily you convert this from a 3D to a 2D. Like this light
By
pulse, which is
ignoring a
dropping.
dimension, yeah. So which dimension are you ignoring to make it two-dimensional? You understand what dimensions are?
Okay, let me, because you're saying I'm ignoring something. What am I ignoring? Tell me.
Perspective, we see in three dimensions, correct? With X, Y, and Z.
Exactly.
In orthographic, we only have a Y and an X, correct?
Let me take you through this.
Where's the Z axis in your orthographic?
Let me take you through this image. It will very easily explain my whole point. We have this is the x-axis, this is the y-axis, and the z-axis is basically the 3D. And we can take a slice of this. We can take a slice from here to here and here. That is 2D. We can represent perspective in 2D very easily. You don't need to have a z-axis to represent to perspective. You don't need. But if you want, you can also use because the z-axis will also have an exponential decay curve, and that's why you can even see when artists are drawing, they have everything will go towards a specific
Okay, I'm
point.
going to stop you there quickly. Again, you got an X and a Y there. Where's the Z axis in that orthographic?
There's no z-axis because I'm representing it in
the Z-axis, so therefore it's not perspective based.
So okay, so what you are saying is you can't represent perspective in 2D.
Nope, because you have to ignore one dimension because orthographic is two-dimensional.
Then if you are saying you can't use if you are saying you can't use orthographic to represent perspective, then why did you use an orthographic chart to conclude that the Polaris drop is based on perspective?
If you try to
actually, that is what you said. You concluded using a wrong curve representation of Polaris, and you later concluded that is because of perspective. So you are saying I cannot do it, but you are also doing it.
No, if you paid attention, I just want to quickly say thank you, Godzilla37, for your $7 super chat. Really, really appreciate it. He says, how the F, dude, did you measure the angles to Polaris without using human perspective? You can't. No one can. Go home. Exactly. You'll see in three-dimensional perspective. That's all. So it's always there. Thanks again for the super chat. Well, anyway, if you paid attention when I present that diagram, it was me trying to explain perspective in a two-dimensional manner. It doesn't take perspective. Listen,
and that's exactly what I'm doing.
It's trying to explain it, but it doesn't because it's not three-dimensional.
And why then did you use orthographic 2D to try and conclude that Polaris drop is based on perspective?
I just told you, and I want to. Would I quickly be able to share my screen?
No problem. You can share a screen.
Shot. I'm going to quickly, because I also actually decided. Let me. Wanna.
By the way, can I respond to Godzilla 37?
Oh yeah, go ahead.
So he's asking me, did you measure the angle to Polaris without using human perspective? That is a very stupid question, because how can you measure altitude of Polaris without measuring altitude to Polaris? Some things are just stupid. Anyway.
Can you see I've updated diagram, guys.
I see.
You can
I
it's
see.
on the screen.
I see. I see. It's a new. I see. It's a new thing. Yeah.
Yeah. Okay. So anyway, I've made all the distances the same now on the bottom because they're all
That's
complaining,
nice.
blah blah blah.
Exactly. That's very nice.
So the top one's just showing those lines going through, and it's creating a kind of bell curve once it's gone through the 90. The one underneath it, it's just in cutting it off there, showing that's where they stop. Now, once I've taken that, I've just pasted 4 quadrants together. It kind of makes a sphere. So it's an inverted sphere. And let's put it around, and it's just another inverted sphere. That was just for the fun. But now we get to the fun part. You see this bottom one?
Yeah, I can see it. Yeah.
Okay. Look at these lines at the bottom. These are the distances from the from the angle, the hypotenuse. Do you understand? So that's the hypotenuse, the 10-degree angle. That's a 20, blah blah blah. And I've just taken those distances to the 90 and just made them 0 degree again. Can you see this curve happening here?
Yeah, I can see. I can see.
Now, is this based? Would this show that they would have a compression?
That's a very good question, because that is one of the things I think, from my own perspective, from my own opinion, you are misrepresenting about this. Do you know understand what perspective compression is? Perspective compression is you are comparing the angle drop with distance. The distance is to scale.
That's exactly what this hypotenuse is, because the hypotenuse changes with distance. That's what gives you apparent angular measurement, correct?
Can you repeat that point?
The hypotenuse, it changes with distance.
The hypotenuse changes with this, and definitely it will increase.
Right.
In that curve, in that graph, yeah.
So 45 degrees, let's say that would be the perfect triangle now, I'm saying, okay?
Yeah.
Everything underneath 45 degrees seems to increase in distance with the hypotenuse, correct? And it shows it in a curved manner. Now, everything above 45 degrees becomes less with distance, and it also shows a curved manner, because remember, I can go and I can do this now degree for degree, and it will make a perfect.
And exactly. Let me just interject, because this is exactly what I'm saying. You are not measuring. Compression isn't measured against. This is how you measure compression for perspective. You measure compression distance. You can see the distance is already the same, and at every point from that distance to at the top of Polaris, you can see the angles. The angle, it keeps reducing at 10 degrees, so there's no compression.
You're saying there's no compression with 10-degree changes. Are you saying if you go stand and measure Polaris, it's at 45 degrees? You're not measuring it at 45 degrees.
Let us do this. For example, the person standing at 2,400 nautical miles. I can
debunk you like in 2 seconds with this.
You cannot debunk me because.
Have you ever seen someone take a video by measuring Polaris's angle and going away in distance and doing a constant measurement of Polaris angular angles and seeing it not compressing?
Could you repeat that question?
Have you ever seen anybody take angular measurements of Polaris and move further away while taking angular measurements to make sure it doesn't compress in the distance as you move?
It doesn't compress, because you can even you see this is the thing which you do not understand. Even this graph which you are showing, it does not show compression, because the distance increase in distance is the same, and you do not measure angles at the sky. You measure angles at the flat surface towards the top of the whatever the thing you're measuring.
Would that hypotenuse change of distance show a linear relationship? at every
It's
single degree.
it's a linear. Actually, let me just tell you this: the hypotenuse, it really doesn't matter at this point. What
Yes, it
matters
does.
is
Why
what
are you
matters
going?
is
Why are you running away from this?
the
Why are you running away?
hypotenuse. It doesn't matter because what you are trying
Yes,
to
it's
measure
got
is
everything to do.
distance.
The hypotenuse is the angle. That's what the hypotenuse is. It's the
No, no, no,
apparent
no. The angle is, it's a good thing you've added another vocabulary. So let us use the term hypotenuse then. The angle is where hypotenuse meets the ground. That is the angle. And you'll notice for this graph which you've shown, when you measure hypotenuse and the angle it makes at the ground, it has a constant 10-degree reduction. And perspective doesn't work like that. For perspective, the angle drop will continue to reduce
Okay, let's
faster.
put it this
It
way.
is never constant.
You understand how parallax works, correct?
I understand what parallax is, yeah.
Okay, so when something's further away, does it take a longer distance to make it show compression?
Perfect. You've actually done
Wow.
the right thing.
Okay, tell me when
Let,
last
let
have
me
you
let me let me try and let
when
me try
last
and
have
answer.
you observed when last
Look,
have you observed
let me
something?
answer you about the parallax.
Okay.
Okay, so this is how parallax works. This is exactly what I'm trying to explain to you, and I'm not sure why you're not getting. Parallax exactly happens because of perspective.
Thank
Because
you. So Polaris perspective. You just
no, 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 no,
contradicted
no, no,
yourself.
no. This is exactly what I'm trying to tell you.
Does
Parallax,
Polaris have parallax?
Polaris does not have parallax. It does not have parallax.
So if you go stand at 80 degrees and move and measure it at 7 degrees, you do not have
Do you
parallax
know?
difference.
Let me explain to you what exactly I'm trying to tell you.
Uh-oh.
For example, let us try to see
You're contradicting yourself, right?
I'm not contradicting myself. This is
If you
exactly what
measure
I'm trying
something
to
at
say.
70 degrees and you measure something at 80 degrees, do you have a parallax measurement?
Could you repeat that?
If you measure something at 70 degrees, change distance and measure it at 80 degrees, do you have a parallax measurement?
If you measure something at 70 degrees, then you measure something else at 80 degrees.
Measure the same thing at 80 degrees and measure the same thing at 70 degrees with different distances. Do you have parallax measurement?
How does that even fit with this graph you're showing me?
Parallax works with different distances between to the same observation, correct?
Okay, let me explain with you
So,
what
it
what I
makes a
understand with parallax.
triangle. So it makes a
let,
triangle.
let me explain to you what I mean with parallax. This is what exactly I mean with parallax. Parallax is, for example, a hill which is very far away from you. You will see when you're moving either to it towards it or away from it, you'll notice that the angular drop, it will be very little. But for things which are very close to you, the angular drop will be high, and that is because of perspective. And this curve already debunks that, because when you are going further away from Polaris, angular drop remains constant. And that is not exactly what happens because of perspective. When you are, for example, a hill which is very far away from you, when you go towards it, the angular drop will be very little. But when you are so close to it, the angular drop will continue to increase at a higher rate. And this graph you're showing me is already debunks the whole point of parallax, because the angular drop when you are very close to North Pole is the same as the angular drop when you are at equator,
Okay, listen.
which goes against perspective and the whole parallax thing.
Let's put it this way: Kilimanjaro. You've obviously because you're in Kenya, you've seen Kilimanjaro before. Maybe. I mean,
Okay. Funny thing, I've not even seen Kilimanjaro.
Okay, but let's just say you have, just for the argument's sake, and you are 100 kilometers away from Kilimanjaro.
Yeah.
By an angular size. Now you move 10 kilometers further away. How much difference would you have in angular size change?
The angular size change will be smaller. Will be
now,
small.
Yeah, now you've taken that data. Now you go back to the point where it's 100 kilometers and you move 50 kilometers away. Would you have a greater angular size change?
Could you repeat that last point?
Now you go back to where you were 100 kilometers away. Now you go 50 kilometers further away. So now you're 150 kilometers away, and the first time you were just 110 kilometers away. You would have a different angular reading, correct?
So okay, let us say. So you said as the starting point was 100 kilometers. Then I moved 50 kilometers back.
You moved 10 kilometers. So now you're 110 kilometers away.
Oh, okay, I get you.
How
Okay,
much
so
difference did you see in that 10-kilometer change than
versus
compared
50?
to you moved?
It will be very little. It will be very little because, for example, at 100 kilometers, let's say it's very far from Kilimanjaro at 100 kilometers. Difference between 10 kilometers and 50 kilometers, it won't be that much. And this is the explanation because of perspective. Because the farther you go from Kilimanjaro, angle drop will continue to reduce lower. It will continue to be lower and lower up to a vanishing point where an increase in distance won't lead to any increase in angular drop. But for Polaris, the angular drop directly at North Pole is the same angular drop you get at equator. That is what you don't understand.
Sorry, on equator, the Polaris is like literally touching the horizon, correct?
Exactly.
So you measure it at 0 degrees or just above.
Exactly. Yeah.
Right. So that's an apparent angular measurement.
It's not an apparent angular measurement. That is where you observe it. You can say it's apparent.
Can see it. It's apparent that it's there. It's apparently seen, correct?
So let's say at equator you can't see Polaris.
I don't think you understand really what you mean with perspective or parallax, because you're literally contradicting your own words and you're making my point valid. When you look at something in the distance, if it's further away, the parallax is so subtle that you would not really see angular compression that much. Hence
exactly.
why you okay. So perspective's still there. You're just trying to ignore it based on distance. Now, let's put it based on this 45-degree angle. What distance would that 45-degree angle give to Polaris?
2,400 nautical miles.
Okay, would that be an apparent altitude or an actual altitude of Polaris?
It depends. In a flat Earth, I don't know, because you can't model Polaris on a flat Earth. But on a globe Earth,
on globe and flat.
On globe Earth it's actually, that's where it is. But on flat Earth, I don't know, because you can't model.
Actually, at that distance at 45 degrees. Have you ever done this on a globe before? You do know if you take that and you show it, it diverges away from each other. It doesn't meet anywhere. The further away it goes, the more it diverges. It's actually against the globe, not for the globe. And by the way, those angle measurements you took, are you talking about? It's taken from, what this equatorial plane is. It's an elevation angle from equatorial plane, hence horizontal, not curved.
What do you mean equatorial plane?
Your whole celestial navigation, everything, the angles to Polaris, your latitudes are based on an equatorial plane. It's a horizontal.
Do you know what equatorial means? Equatorial means based from equator.
Yeah.
So that is not what happens.
Yes, it is.
For example, when you say equatorial plane at 30-degree latitude, you are not at the equatorial plane.
Okay. On a globe Earth, your angles are supposed to be infinite. But when you actually model it out, it diverges from each other. It doesn't converge to meet at a point.
Yeah,
and we literally took that measurement from a horizontal. So what you're doing is you're duplicating the horizontal angle to the equatorial plane, hence the center of your Earth globe, so you can try converge those two angles that you measured flat first.
Is it possible? Can you show my screen? Because I've shown it has the graphic for the globe. There's nothing that is converging anywhere.
You do know the sun rays are not parallel. We can literally go. You can go outside in the daytime, and you never ever see parallel
Where,
sunrays.
where do you see convergence or divergence in this thing?
It's a drawing which totally misrepresents reality. There's no such thing as parallel rays.
There is something
And
called parallel rays.
it wouldn't work because you're literally ignoring your argument on refraction now. What happened to the angle? What happened to the angle of incidence with refraction on your globe all of a sudden? Did it just magically vanish?
Angle of
incidence, refraction.
I'm just showing you. This is exactly how it happens on a globe Earth.
No,
it is so simple. When you are at 50 degrees, you can easily measure it.
Where's your refraction?
Refraction is very, actually that is another thing I was talking about. Angle of refraction is very little from what we observe, and it doesn't really affect.
It's not parallel then.
It's parallel. It's parallel.
Refraction doesn't give parallel rays. The angle of incidence has to be perfect, and this is a curved surface, correct? So the angle of incidence will always be different, correct?
Look. This. I'm just showing you. This is how it happens on a globe Earth. Show me how it works on a flat Earth. Show me. Refraction. This is exactly what I was trying to tell you. This is when you try to say perspective.
If you want to,
you cannot. I want you to model accurately Polaris on a flat Earth. Just do that, and I'll be okay.
There we go.
I'm not saying what are you saying? There you go.
Modeled accurately on a flat Earth. It gives exactly the same data for your globe because this is what your globe is based on.
This is exactly my. It's very good. You've shown.
You see this math on the left, yeah? You see
it's very good.
90 blah blah blah. Are you?
And that is called.
Can you confirm that all those distances are correct?
Yeah, all the distances are correct.
Great, and they're all based on a 90-degree angle, correct?
Exactly.
And what is a 90-degree angle?
On a globe Earth, you can explain a 90-degree angle. On a flat Earth, it doesn't make any sense.
A 90-degree angle is perpendicular to the vertical, correct?
Exactly.
Great. So
is it possible?
Listen. So you have a vertical where you're standing, your zenith, and you're standing on a horizontal, which is your equatorial plane.
It is not an equatorial plane. But anyway, I get your point. You're standing at horizontal.
Great. And you're making an angular measurement. So two straight rays or lines to form a triangle.
Yeah.
This is actually a good question from Adam Meekin. Could you ask if the apparent position of Polaris is subject to 7/6R refraction? Actually, he says no, by the way, Adam.
Okay,
he threw it away now with his Globy.
But I have a question with this caveat, which you are showing me, which you are saying is a model of flat Earth. Why is Polaris at 10 degrees lower than at 20 degrees, at 30 degrees, 45 degrees? Why is it lower?
Because the hypotenuse distance.
No, the hypotenuse doesn't matter. Why is it low? My point is, for example,
the compression
when
you say doesn't exist. It's the compression you say doesn't exist.
What?
It's the compression you say doesn't exist.
It does not exist for Polaris, and this is another thing I'm telling you. Is it possible?
If you stand on the 40, let's say in the 40th latitude, and you measured now, are you saying you can't see Polaris at 40 degrees?
You will see Polaris at 40 degrees.
Wow. Okay. Now let's move to a different latitude. Let's go to 60, and you measure Polaris at 60-degree angle.
Is it possible? I just go through.
Listen, did you measure it on a horizontal plane?
On a flat Earth, it's horizontal, but on a globe Earth, it is based on where you are on the globe.
On a globe, listen here, you're taking that angle based on the horizontal, because even on your globe, you're measuring on a horizontal plane, hence elevation angle. What's an elevation angle?
Elevation angle is where the hypotenuse meets the horizontal.
Great. So you measured it flat first.
So, okay, is it? You're saying if I measure it flat first, it doesn't matter on a globe. This is another thing flat earthers don't understand about the globe. The globe is not a basketball.
We're talking about elevation angles.
Because I've had this question and it usually makes me laugh. They think because we are on a globe, you can't have a horizontal axis. They think it's a basketball. It's 40,000 circumference is 40,000. When you are when even the basketball is 40,000 circumference is 40,000 kilometers. When you are on top of it, it will appear flat.
Is a circumference flat?
But let me ask you a question on this. The thing
flat?
Let me just ask you two questions.
I'm asking you: is the circumference flat?
Circumference is not. Circumference cannot be flat or whatever. Circumference is just the total distance.
It's the boundary to your radius, because a radius is a straight line.
A radius is when you, for example, you take a ball or a circle. Radius is like half the distance to the center, from the circumference to the center.
So a straight line?
Yeah, it's a straight line. Radius is straight.
To a circumference. And the circumference, you do know your ball has a circumference. So it's not horizontal.
It's not horizontal. I know that.
Draw a circle quickly. Draw a circle and draw a horizontal line and tell me how they fit together, please.
You're saying draw a horizontal and draw a circle.
Yeah, and tell me, do they look the same?
A horizontal and a circle. I'm not even getting what you're saying.
Can a horizontal curve to look like a circumference circle?
Can
a horizontal curve?
Okay, so this is. Do you know what a tangent is?
Yes, it's a straight line to a point on a curve.
To any point. Exactly. We get for globe. We get our horizon and horizontal from the tangent.
You haven't answered me yet. Does a horizontal curve?
You know, like I don't even get your point. That's
horizontal curve. When you take an angular measurement, angle two straight lines on a horizontal, you got an apparent angular measurement. It makes a triangle, correct? And the GP of that star would have a 90-degree on that triangle, correct?
Yeah.
So it's on the horizontal plane. Okay. Now, do you get the issue here?
What issue? I don't get the issue.
The issue is, let's say I am measuring optically, three-dimensional, 10 degrees to Polaris. So I'm 4,800 nautical miles away.
Yeah.
I measured it on a horizontal, which completed a whole triangle, and Polaris was 90 degrees from me.
Continue.
So I created a horizontal baseline of 4,800 nautical miles, no curve.
So what is the point? I'm not getting where you're going.
What is the point? No curve. That's the point. It's horizontal. I mean,
I don't even understand. So how is that relevant to a globe? Look, because you're trying to debunk a globe. How is that relevant to a globe?
I'm not debunking anything. You came and tried to present how flat Earth doesn't work on Polaris and how it only works on a globe.
Is it possible?
You showed your globe having parallel rays, which is false, ignoring your refraction, your terrestrial refraction from that.
So this is my question. This is
showing you don't understand.
Pardon. This is the problem. This is the problem I have with you. Show me evidence that parallel rays don't work on the globe.
It doesn't.
Show me evidence that parallel rays don't work on globe. It works on globe because even the sun rays come parallel to Earth.
So no
The
refraction.
stars, yeah.
So no refraction then.
I don't know about the refraction, but what I know is I've already shown you how it works. I'm not sure about the refraction, but this is the point I'm getting to. You've shown me you have a very nice graph in front of us. This is my question to you. How come when you draw a straight line, the 10 degree, it doesn't, why doesn't it merge at one place? Polaris should be at a single point. Why is it not intersecting at one specific point in this curve you are showing?
Sorry, I told you why it's not, because it's an apparent angular measurement.
What causes that apparent angular measurement? What causes the apparence?
Perspective.
No, perspective doesn't cause it because.
Can you see my screen? Can you see my screen?
Yeah, I can see your screen. Yeah.
That's the sun, correct? Are those light rays parallel?
This is another very flat Earth. This is another flat Earth.
Are those light rays parallel?
It's parallel. Yeah, it's parallel. It's parallel. Go up.
That is parallel. Remember,
let me show you.
Let me show you. You said the sun doesn't have perspective either. Now,
these are parallel rays. Have you ever seen a railway track? Have you ever seen a railway track? A railway track that goes away from you.
Can I explain perspective to you quickly? When you stand at a railway track,
these are parallel rays from the sun, but it appears to be divergent because of perspective.
So, but you just said 2 minutes ago there is no perspective. Okay, can I explain to you how perspective works? When you look at something in a distance,
it's exactly like this. So what you are trying to say? What you are trying to say is that these railway tracks are not parallel because they are divergent.
Can you stop talking over me?
Okay, no problem. I can
Thank you. So, you know how this works. You are looking out in the distance, correct?
Yeah.
That apparent position of that railway tracks converging, not diverging, are they actually that close together, or are they apparently that close together at that position?
They obviously are not divergent. They won't touch because they are parallel.
Because perspective works from the observer to observation, not from observation.
This is perspective
to the observer. So when you claim this sun is just perspective, you are literally making my point. It's diverging towards you. So it's from the observer converging to the sun. No parallel light rays. You've debunked your own.
That is parallel. This is exactly what you have told. This is just like the train. What you are telling me. You can see they will never touch. These are parallel rays. They will never touch. It is like saying the railway is because the railway line, because you see it's like they are touching. So you are saying they will converge. They won't converge. These are parallel rays. All these are parallel rays.
Okay, look at the sun. Is that converging? Is that showing convergence or divergence?
Those are parallel rays from the sun. It will never converge. It will not. It is not diverging.
Show me a ball that has parallel rays, please.
A what?
Show me any spherical light ball that has parallel rays, please.
Any spherical what?
Show me a spherical object that emits light that has parallel light rays, please.
Okay, I'm not even getting. What's the point with all this?
You're getting demolished at every turn, yeah, mate. Literally. I'm sorry to be blunt, but you're literally way out of your league here.
I'm not way out of my league. You evaded all my arguments. Then you've started to create about things I don't even understand. How does
you know what I'm taking? I've taken them, I've picked them up like this, I've pooped on them, and I've thrown them in the toilet, and I've flushed it down. That's what I've done to your arguments, and I haven't even I've started warming up on your arguments, literally.
You've evaded all my arguments. You've not responded to any of my arguments. And the funny thing is, you are repeating what I've already explained in my point. This is one of the questions I've asked. I've asked you, why are all the different rays not intersecting at the same place? You are saying it's because they are apparent rays, and I asked you what causes can you model it on a flat earth and show me exactly what it causes the apparent position to be not to be at the same place, at the same position, and you have not shown that. And you are trying to tell me about perspective, and the thing you are showing me is showing a linear constant between distance and angle drop, and you know very well perspective. This is, you can see, you see every point, for example, at every single distance increase, it has a constant angle drop, and that is against perspective. You have not debunked anything. You are just evading my questions, and you have not answered anything.
Okay, so again,
this is my question. This is my question.
Wait. So the hypotenuse distance changes with every angle, shows a linear relationship, correct?
Let me explain what causes the linear relationship.
Does it show a linear relationship or not?
The hypotenuse does not matter. What matters is the distance and the angles.
Hypotenuse does not matter for angles, guys. What is an angle?
Do you know what hypotenuse is? Hypotenuse is not an angle. Hypotenuse is the distance between.
Me an angle without hypotenuse, please.
What matters is the distance from.
Show me an angle without a hypotenuse, please. Go ahead.
Do you know what hypotenuse is? Distance. The slanting distance. It does not matter in this argument.
So can you have an angle without an hypotenuse then?
You don't get the point. The angle matters. You cannot have an angle without hypotenuse, but the hypotenuse distance does not matter. What matters what matters is the horizontal distance and the angle it makes with the hypotenuse. That is what matters. And from this graph, let me just show you this graph which you are showing me. You can see there's a linear function where an increase in distance leads to a constant drop of angle, and that goes against polarity. That goes against perspective. Perspective increase in distance will lead to compression, and you already know that.
And what am I showing? What's my cursor going over here? And can you see my cursor? There. What is that showing?
I can't see your cursor, man. I can't see your cursor. Oh okay, yeah, I can now see your cursor.
Yeah. What is it showing?
I think that's the hypotenuse.
Right. And what is this curve kind of thing happening with distance?
That is just bullshit. Doesn't affect anything.
Is that a linear relationship based on
this is exactly why you don't even understand what you're doing. You are trying to measure. You're trying to measure the hypotenuse. We are not talking about hypotenuse. We are talking about the horizontal distance with angle.
Sorry, does a hypotenuse have a distance to a GP? So let's say I measure 3,000 nautical miles. Okay? I measured let's do 45. I measured a 2,700 nautical mile thing, for instance. Okay? 245 degrees. That hypotenuse has a distance to that GP of Polaris.
Exactly. And
it has a relationship to the horizontal, the other ray that completes the angle, correct?
Exactly.
Okay, so that hypotenuse distance shows why it has compression, because that distance changes with angular measurements. An angle is physically, literally, the hypotenuse measured angle over a horizontal.
Exactly, so that is the angle.
So, thank you. Me showing a linear relationship for your arc based on the horizontal thanks to the hypotenuse, is you conceding that it's a flat Earth.
Okay, so this is exactly what I'm talking about. These lines don't mean anything. They do not mean anything. What
Explain to us
matters?
why they don't mean anything. This
They,
should be
they
good.
don't they
Explain
don't
why.
mean any, they don't mean anything, because what we are trying to measure, when you are saying 90 degrees minus 90 degrees is equal to 0 times 60, what you are trying, those you see, this 90, 70, all these are angle, these are angle. This is the Polaris angle, angle from the horizon, from the horizontal, or whatever you will call, versus the distance. Where have you even talked about the hypotenuse in this 90 minus 90 is equal to? You've not talked about the hypotenuse. Does not matter in this
Okay.
in this argument.
Let's put it this way. What is a 30-degree angle? Is that a hypotenuse?
A 30 degrees angle is what between a hypotenuse and the horizontal.
Is a 30-degree angle the hypotenuse over a horizontal?
It is the angle that makes when hypotenuse meets the horizontal. Yeah, 30 degrees. Yeah.
Great. So the hypotenuse then is the measured angle.
Hypotenuse is not an angle. Hypotenuse is
The
this
measured angle.
hypotenuse is the slanting, like there are three sides to a rectangle. Hypotenuse is the longest distance on a triangle.
Yeah,
So hypotenuse is not an angle, and
show
hypotenuse,
me an angular measurement without an hypotenuse, please.
you can measure like the 90 degrees. It doesn't have hypotenuse.
90 degrees still has an hypotenuse.
It doesn't have an hypotenuse. Hypotenuse is
It's a vertical. The hypotenuse is vertical.
No. You don't even understand what hypotenuse is. Hypotenuse is the longest distance on a triangle. That is what hypotenuse is. You are trying to tell.
When you have a 90-degree angle, you have a triangle. Then it creates an hypotenuse from the two openings, correct?
Let me just read for you what hypotenuse is.
Do you get what I'm saying?
This is now in geometry. Hypotenuse is the longest side of a right angled triangle. You see, so hypotenuse is the longest distance. But at the 90 degrees, it's not the hypotenuse. There's no at the 90 degree mark. There's no hypotenuse intersecting with anything.
Draw quick. Can you quickly do me a favor, draw a 90-degree angle and close the angle quickly and show me where there's no hypotenuse.
You see, now we are wasting time. That doesn't matter.
You are double speaking constantly, validating my arguments constantly, and this is literally a comedy show. I'm not even sure if you're serious or not.
I don't. You see, at this point, actually, I think you guys are so far gone. And this is another thing I'll just tell you guys.
On screen explaining every single thing to you that you guys say is impossible.
Hypotenuse, I told you.
You asked me to go and present to you how it would work. I'm showing you, and you cannot deny every single thing here is perfect. Are those angles out? No. Is it showing compression? Yes. Are those?
It does not show compression. It does not show compression, and it does not show compression. It does not show compression, and the fact that you can even have a linear function where you can multiply whatever 90 minus 20 is equal to 70 times 60. It exactly proves my point. There is no compression. It is linear function. Compression happens when it's an exponential
every single
function.
Angular measurement you take shows 45 degrees. Every single one of them. Doesn't matter what distance you go, it shows 45 degrees.
No.
Great. So in reality, it shows compression. Thank you.
Do you even know? Okay, I think let us start by definition. What do you mean by compression?
Perspective. It has an apparent drop in the distance as it gets closer together. You see these lines again in the bottom, those hypotenuses that are made 0 degrees to lie horizontal. Those hypotenuse distances are those angle measurements just laid horizontally flat to show the relationships between the angles. Now, if you had to do, you can literally go and take this and do 1 degree at a time, and you would get a sphere, arc, a linear relationship. based
You
on a
don't even know what perspective is. Perspective can never be linear function.
Sorry.
Perspective,
Tell me
perspective,
I don't understand perspective. I
angle
majored in
drop.
art. I studied art. I literally majored in it. I got
Exactly. And if I was your teacher, I would have failed you.
I got 4 distinctions in art. And you tell me I don't understand perspective.
You do not understand. You do not understand.
Yet I'm
If you
educating
can't
the whole
if something this easy you can't understand, you are a lost case, my
don't
friend.
understand. No, you don't understand. You don't even understand the difference between a left and a right foot at the moment. Tell me again how the sun rays are parallel. Tell me again how the sun rays are parallel, or tell me how refraction doesn't exist according to your globe geometric thing you showed us while you claiming there's refraction. Also, please explain to me how there's parallax but no perspective when parallax is part of perspective. Also explain to me how things do not have perspective when you're looking 3 dimensions, and explain to me why parallax does exist and not exist at exactly the same time, and also explain to me how you can have refraction in one medium.
I already explained the point of parallax, but you do not want to listen. So what's the point in repeating?
Everybody's laughing at you. Thank you for presenting, but you literally just made a fool of yourself. I'm sorry, that's just how it is.
Okay. Let me just say this: the Earth is a globe. Whether you guys don't want to admit or not, is that, and this is actually my honest opinion. You guys, you are wasting so much time on very useless things on flat Earth. And this is just my opinion. Like it I don't know if it makes you feel important or what, but
no, debatable. Yes, 4 distinctions. That means 80% over. Graphic design, I got 97%. By the way, sorry, MediaDon. I just have to say this. I was going to say something, but just because you say we're wasting our time, this is a flat Earth channel. You come here.
Oh, actually, you are not wasting your time. Flazo, you're not wasting your time. At least you are making money. But the guys following the other ones.
Not much. The little money I make is literally paying for my child's school. That's the little bit of money I make, and the little bit extra I try and save for equipment for the stream. That's about it. I mean, you probably say you also know in Kenya that's not a very rich country. You don't really get that much.
Actually, I'm employed remotely, so I can make a lot of money.
Great. So, but were you an always remodelist, or did you have to work to get there?
Definitely, I had to work to get where I'm at.
So I had to work to where I'm getting now. My channel's still quite new. I'm working to get where I'm getting. I'm not making the money that I need to, unfortunately, because the rand rate is also rubbish and economy is falling apart. But like I said, one thing I can tell you for certainty is the Earth is flat. Based on every single debate I've had so far and everything I've been explaining, I can guarantee you it's not a globe, because all we get from you guys is, you don't understand, you're a moron, I believe it's this way, I can't demonstrate it because it's scale or math. That's all we get. And when you guys ask us to do something for you, like hence this graph, we show you to be absolutely wrong because you said you can't present it, which I certainly did. You ignore the information presented. That is it about it.
I don't even know what to say, but anyway, I think for you, Flazoid, it's not even about the truth at this point. It's just about.
That's what it's all about the truth.
I think for you, like this is my honest. This is my honest opinion. For you, Flazoid, it's not even about the truth. It's about an ego thing. You cannot listen to any contrary opinion. Whatever I've presented, you have not even argued anything out of it. You come up with totally different. I've asked different question. You come up with different. I don't even know what to say, man.
Wow, I'm not about truth, and I haven't argued one thing yet. We got a thing on screen, literally debunking all 3 of his arguments at once. That is profound. Maybe you
belongs
should
you.
stop projecting. Maybe you should stop projecting and actually pay attention when I give a rebuttal, because you've literally contradicted yourself. I think I counted at least 8 or 9 times, because you get pushed into a corner after I gave an argument, a rebuttal to your questions. So
Tell me
now you
one
can
thing.
be shown as a
Tell me
liar.
one thing where.
You can also be shown as a liar now too. Then
Tell me one thing which I contradicted myself.
okay, let me just first say thank you, Adam Meekin, for your £10 super chat towards the schooling. Thank you, Numpty, for reminder. Flawless victory, mate. Thank you very much for the super chat. Really, really appreciate it, Adam Meekin. Yeah, it was actually no trouble at all. It was the easiest debate I've had, to be honest. Okay, what have you contradicted yourself? The sun is not perspective based, yet you're claiming it's parallel and convergent.
The sun rays reaches Earth in parallel. That is not a contradiction. That is
You
a statement of
literally
fact.
said a minute before that the sun does not have perspective, and then you're saying it's got parallel light rays that's showing divergence, which means perspective.
No. There is no contradiction. Is it possible? Can I explain myself? Can I explain myself in that point? Can I explain myself? The sun rays are parallel. The sun rays are parallel. But when you see when the image you showed, it shows it appears to be diverging, but it's parallel. It's just like the railway tracks.
So
There's no any.
So perspective. You contradict yourself now again.
What don't you understand? Something can be parallel and have perspective. A railway track is parallel and it also has perspective. Is that so complicated to understand?
You said the sun does not have perspective, but it is showing divergent rays.
I never said it's showing divergent rays. I said it appears to be diverging or whatever converging, but it is parallel.
Perspective. It appears to diverge.
But you okay, let me ask you a more relevant question. Do you agree that Polaris goes against perspective?
No. Nothing goes against. Sorry, I got another super chat. Thank you, Godzilla37, for the $7 super chat. Really appreciate it. It should be called Dunning-Kruger. Am I right? Yes, I think it should be. Thank you very much for the super chats. You guys are all awesome. Thank you again, Godzilla. You guys rock. It's very simple. Everything we see in three-dimensional reality, aka including Polaris, has perspective. You even conceded that when you said there's parallax. Or are you trying to say there's no parallax?
Okay. Let me just repeat my. Can I share my screen again? Is it possible?
Yeah. Before you do that, can you just give me one question before you do that? Your eyes. Do you have parallax with your two eyes?
Oh, I don't even know how to answer that. How between my eyes, parallax is caused by what you are viewing, not your eyes.
So your eyes do not show parallax then?
I don't. What actually? Let us start here. What do you mean by parallax?
Exactly what it is. It gives a different position, apparent position, based on your vantage point. That's what parallax is. It's perspective based.
So
three-dimensional.
This is my question. Why does Polaris have a different curve with, for example, Polaris behaviors observed from North Pole? Why does he have a different, why does he have a linear curve while perspective of any object on a flat surface?
Why does it have a linear curve? I'm going to put my thing again. The hypotenuse. There's your linear curve. The hypotenuse.
What about the hypotenuse?
You asked what gives the linear curve. The hypotenuse gives the linear curve.
Are we even talking about the same thing? Because I'm plotting angles and distance. Where does the hypotenuse come in that equation? You can see where in my
Part
graph
of
have I
the
put by
angle.
hypotenuse?
The hypotenuse is part of the angle. That's where it comes into play. The distance of the hypotenuse is longer usually than the horizontal, correct?
Yeah, definitely.
Great. So would that give an apparent distance hypotenuse angle measurement?
Apparent distance hypotenuse angle measurement.
Let's put it this way. The hypotenuse is an apparent angular measurement which is longer than the horizontal distance. So in other words, when you plot the hypotenuse out as a horizontal, it
You
makes it
cannot plot
longer.
the hypotenuse. You
It's
cannot plot the
longer.
hypotenuse. The
You can take
hypotenuse does
this.
not matter.
If you
Okay,
you saying you can't take, you saying you
let me
can't
ask you. Let me ask you.
saying, can I finish
Flatwood,
my statement?
flatwood, flatwood,
Can I
flatwood.
finish my
Let me ask you a
statement?
question.
I want
Let
to
me ask
finish
you
my
a question.
statement. I
Let me
just
ask
want to
you a
finish my
question.
statement. I just
Let me
want to
ask you.
finish my statement. I just want to finish my statement.
Okay, no
Okay?
problem.
The hypotenuse distance is longer than the horizontal. So as soon as you take that hypotenuse and you plot it out on a horizontal, it gives your linear curve because every single degree laid out once together from the horizontal gives a linear curve.
So, can I ask you my question?
Go ahead.
For example, when you are at 2400 nautical miles, do you know the distance of the hypotenuse to Polaris or to anything? Do you know the hypotenuse, the distance of the
If you got
hypotenuse?
your distance on the floor to Polaris, yes, you work out your hypotenuse. Should we go and get a triangle calculator to do that quickly?
No. This is my question. This is my question. And this is exactly why I'm telling you the hypotenuse does not matter. Because when you are at 2400 nautical mile from the North Pole, and you know the angle, the hypotenuse, it matters because obviously you need to measure the angle, but the length of the hypotenuse is not relevant. And that is why I have not plotted it's irrelevant because it
A
doesn't
hypo-
matter. The
it's the first.
hypotenuse, you can to measure an angle, you don't need to know the distance of the hypotenuse. You just need to know the angle
The
between
angle
hypotenuse and
measurement is the hypotenuse. That 30-degree angle is the hypotenuse.
30 degrees, not the hypotenuse. Do you know hypotenuse is distance, the longest
Yeah,
distance.
that guy is looking up 30 degrees. He is measuring a hypotenuse to the 30-degree GB. That is a
It's measured.
hypotenuse distance that he's looking at. Are you saying he's not looking 30 degrees when he's
He's
measuring
looking
30?
at 50 degrees. But I'm just telling you, when we are calculating the perspective drop versus distance, it doesn't matter the length of the hypotenuse. It does not matter.
So I can say a 30-degree and a 45-degree has the exact same hypotenuse because it doesn't matter.
So this is okay. Let because you're asking, let us go there. You can have it doesn't really matter because what matters is the distance from North Pole and the angle and the altitude angle. You see these lines you are drawing, it is irrelevant. It doesn't really make any difference.
It shows the relationship for your beloved curve. That's what the hypotenuse line sitting horizontal is showing you.
You see,
That's why
this
we
is
did
the
it.
problem.
That's why
This is the,
specifically we did it. Why does this trigger you, Glover, so much that we can literally show you a working graph model that you says is impossible to work? Why does it trigger you guys so much?
this is the problem I have with you, Fladswood. You misrepresent everything, then you use conclusion based on the misrepresentation. And I
What
can
did I
even show
misrepresent?
you.
Please show, what did
Can
I
I share my
misrepresent? What
pardon?
did I misrepresent? What did I misrepresent?
Can I share what you misrepresented? I can show you.
Yeah, go ahead.
I have it here. Okay, let
Yeah,
me
go
see if
ahead.
I can
And
share
if
this.
you share, I can click it on. I hope you guys are all enjoying the show. My jaw and my cheekbones were actually quite sore now from all the laughing and smiling. Hey, Skeptic, good to see you, mate. And thanks everybody in chat. I haven't said hello to you. It's good to see you all. Okay, there we go. Brought out my old two. You do know I have been updating these graphs the whole time. That's why I got this latest
The
graph.
reason why you need to keep on updating is because you're misrepresenting.
No, because we keep getting straw man with different arguments, and then
This is exactly what you did. This is exactly what you did with Sean. You said this is exactly what you need. And you say this. You say that this debunks Sean.
It does.
This is exactly why I'm saying it does not, because Polaris angle drop.
Sean literally made a real three-dimensional model confirming this, literally in his hand with sticks and papers.
Okay, let me just take you through why this does not represent the reality. First of all, Polaris angle drop at a place denotes the ground position latitude. So, for example, when you are at 50-degree latitude, it means you are at 50-degree latitude on the Earth. But you're trying to show one person can observe Polaris at all these different latitudes. And that is exactly what I say. This means that the person is standing at North
You know
Pole.
what a straw man means? You know what a straw man means? You know, there was a context to what I did there. I even said it out. The guide is just standing there just to show you in context that he can measure all these at different degrees like a protractor. Obviously, he's not
you cannot. You see the thing
he's not going to see them all at the same distances. Hence, you see the outsides there with the distances. Yeah,
and that is the thing. When
this is called a straw man, and you misrepresenting my argument.
Okay, let me show you. Let me just go straight to the point. What are we seeing here? We are seeing one person observing Polaris at 80, 70, 60, and then you came up with a conclusion based on this chart. So this is exactly what I'm saying. If this guy is seeing Polaris at 40 degrees, he cannot also see Polaris at 50, at 60. Why it cannot happen.
That's false. How did you get the apparent measurements then? You go to 50-degree latitude, you see Polaris at 50 degrees.
This is exactly what I'm trying to tell you. So this guy is seeing, when you see Polaris at 40 degrees, it means you are at 40 times. It is even here 40 2400 nautical miles from this guy. If this angle here is 40 degrees, then this guy is 2400 nautical miles from the North Pole. So how can that guy also see 30 degrees? That will mean is also at 30-degree latitude, 80 degree. It doesn't work. And this is exactly what we're doing.
Sorry. What doesn't work? Do those distances match the latitude measurements I put there?
Look. The first
match the latitude measurements I put there. Do those distances match?
And this is exactly what I was getting to.
Simple yes or no. Do the distances match?
I'm answering your question. You use the correct data, but you misrepresented the data. Because a person at 40, a person at 40 degrees, a person seeing Polaris at 40 degrees cannot see Polaris at 50 degrees at the same time. So whatever this chart you have drawn here is irrelevant.
Because it's 600 nautical mile difference. When last have you seen over 600 nautical miles? No one has superhuman vision. That's just, again, you straw manning my argument. The guy has to literally move 600 nautical miles to see the next 10-degree difference.
And this is exactly
your own argument. Hence why you debunked your own argument that you said you don't see compression with Polaris. No one can see all the drop of Polaris by themselves. When last have you traveled from the North Pole to the equator, looking back and seeing no compression or compression? When? You can't.
Can I ask one question? This is a chart. It is supposed to represent data accurately. This guy is looking at 80 degrees, 70 degrees, 60. These are all Polaris. And Polaris at 80 degrees means this guy should be at 600 nautical miles. So when you plot when you say this guy can also see at 70 degrees, at 60, You
That's
are
not the same guy. Again, you're misrepresenting my argument. I literally said the guy standing here is just showing the protractor. It's just to say, look, he's looking out at the stars. He's not. This is a straw man. This is not him standing at the same position, looking at all of them.
but what?
You
But
understand?
this is a
He has to
person.
move position. He has to move position. Hence,
This
you
is
see those at the bottom
you
moving
see.
position to look at the same star.
Okay, this is exactly what I'm talking
You're
about.
asking for straw,
You are
mate.
trying. You are. This is the real representation of what happens. This is your own strawman representation of Polaris, and you are using the strawman representation to come up with a conclusion, which is false. And this is exactly what you have.
Okay.
You are.
Okay.
Which is
I want you to explain to me how I have made a straw man that I'm coming to a conclusion. This should be interesting.
these are the points. These are the points. Polaris angle.
How about straw man myself and come to a conclusion based on my own straw man of myself?
Exactly.
This is
You
the
did.
first.
That's
This is the
exactly
first.
what you did.
Explain it to
You
me.
used this chart, which cannot happen in real world. Then you came up with a conclusion saying that there's compression and all that. That doesn't happen. You are trying to tell this guy. This guy is when this is a 30-degree angle of Polaris. Polaris is used as a navigational tool. If a person is looking at Polaris at 30 degrees, he cannot see Polaris at 40, 50, 60. You cannot see that.
Shit, Sherlock, because it's position based. If he's standing and he's looking at Polaris at 30 degrees, he knows he's at 30-degree latitude.
Exactly.
So,
then exactly this is
why
what
would
you
you think-
this is
is
this
there-
is what you are
sorry,
this is what you are trying to do.
Sorry, there's only one Polaris, correct? Or is there now 10?
This is exactly what you are trying to say. This
How
is
much Polaris are there?
at 30 degrees. This is 30 degrees. This guy should only be at 30 at 3600 nautical miles. But this guy is standing at the same place and he's observing all these different Polaris or whatever conclusion you come up from this chart doesn't make any sense. And this is exactly what you are doing with the hypotenuse. You are coming up with you create your own nonsensical charts, then you use the nonsensical chart to quote unquote debunk something, which is bullshit.
No, the only bullshit is you misrepresenting my argument and you're telling me I don't understand while you're literally showing you don't have a cooking clue what you're talking about. First of all, how do I strawman myself?
You did not strawman yourself. You strawman the argument of Polaris.
Again,
this is another thing. These are the 3 points. Let me just.
Do those distances match reality?
They match reality, but
there's no strawman there. Do you see Polaris at 30 degrees at latitude 30?
This is exactly what this is exactly what I was saying.
Do you see Polaris 30 degrees latitude at 30?
Exactly. You see that
at that distance. Okay, so the data is accurate.
Data is accurate, but the chart is
Where
inaccurate.
is the straw man?
This is how you should have drawn it. This is exactly how you should have drawn it. What we observe in real world is moving from Polaris. Not one person standing at one place, then observing all the different.
Polaris doesn't move. The guy moves. So you are strawmanning me now.
What is this? What is this? This is Polaris moving.
The angle comes from a vertex. That would mean the guy observing is the vertex.
Can I ask you one question and one question alone? Can a person standing at 30 degrees, what does that mean? It means that guy is at 3600 nautical miles. How can the same person also observe Polaris at 40 degrees? That will mean that person is standing at both 3600 nautical miles and 3000 nautical miles.
Oh, so you again, like I said, you are strawmanning this. The guy here is not standing at the same place. This is just representing to show the guy is looking out like a protractor.
And that does not happen in real life.
Listen, I don't know if this is getting clear to you. You see those distances at every angle measurement shows his distance from the bloody star. So it changes. He's not standing at the same distance looking at them all at the same time. So you are strawmanning me.
I don't even understand why this is so complicated.
I wish I could
what
speak your language to maybe try and explain to you another way.
Anyway, the point is, whatever conclusion you come up with from this chart will always be inaccurate, because this is not exactly what we see.
You
in real
literally
world.
considered all the information is correct. So what is inaccurate about it?
What is inaccurate is how you this is exactly even what I said. This is exactly, this one person cannot see Polaris at 50, 40, 30. It can never happen. But this is exactly, this is the real
Okay.
world observation. This is your own fake observation.
Sorry, before you go, I just gonna say, Godzilla 37, thank you very much for your $7 super chat. He says, this is costing me too much money. Don, you lost about a minute after your initial presentation. Go home already. Thank you very much for the super chat. Yeah, like I said to him, you saw me start laughing in like 20 seconds into his presentation because he literally debunked himself, contradicting himself in his own presentation. So yeah,
how did I debunk myself?
Polaris has no perspective.
Because it goes against law of perspective.
How? When last have you
how many times do I have to go through that?
You still haven't answered me. Can you show me someone looking at Polaris, going away from Polaris, and seeing it not drop due to perspective?
Could you repeat?
Can you show me someone observing Polaris, moving away from Polaris, and observing it drop into the horizon without having perspective?
Okay, let me share my other presentation to go through. The problem is you guys are not listening.
No, the problem is you don't want to accept that you are falsely wrong or beyond many levels here. Just making a claim and not being able to back it up is what you're doing. Like I said, can you provide me any evidence that Polaris is not perspective based? Because the only way to provide that evidence is to actually have an observation of someone looking at Polaris, going away in the distance, and it not dropping due to perspective. And what happens when we look at a star when we go away? It drops due to perspective.
Okay, I'm sharing my screen.
Mm-hmm.
I don't know. I don't understand. Is it so complicated or what? This is exactly my point. Okay, let me just go through this thing very fast. Perspective is an exponential decay curve. The drop at if you are using this thing to represent Polaris near the North Pole, the angle drop will be large. But when you are going further and further away, close to equator, there will be more compression, and the angle drop will not be the same as.
Again, when last have you observed 600 miles away? Have you ever done an observation which is 600 miles in difference?
You see, the thing is, it does not matter.
Have you ever done an observation in 600 miles difference? Yeah, let alone, let's just say 60 nautical miles. 1 degree. Take 1 degree. When last have you done observation with 1 degree?
You see, this is, I think that is called it's called genetical fallacy.
No,
you don't have
not.
to do everything. The thing is,
at 600, want to back up.
At 600 nautical miles, you even know it's 80 degrees. I don't have to go there to measure myself.
If you make a claim, it's your burden of proof to back up. So, like I said, have you measured 1 degree, which is 60 nautical miles or 69 statute miles, correct? Can you see 69 statute miles with an observation usually, which is usually hard, correct? Mm-hmm. So if you move now double that to get it 2 degrees of drop, are you going to see the compression in 2 degrees of drop?
With Polaris or with any other thing?
Polaris.
Okay, so this is exactly, I don't
know.
Will
you see the compression with 2 degrees of drop?
When you
and have will you see the compression with 2 degrees of drop?
There's no compression because it's a linear curve.
Again, the hypotenuse gives you a linear curve on a horizontal. Now, again, like I'm saying, so you cannot tell me that there is no perspective based because it's all just a belief then, correct? You believe that there's no perspective then because you cannot prove it.
I can prove it. This is exactly what I'm trying to prove.
Where
When
have
you
you
plot,
proved that?
when you plot
You made a
Polaris,
claim that
angle
has
drop
dropped
is
your
linear, but perspective of every other thing on Earth is
again, orthographic view is two-dimensional. You are throwing away a z-axis dimension, aka perspective, to say it's perspective.
you see that's the funny thing. I do not need you can represent the drop using 2D. And that is why you are even trying you even all do you have a 3D representation of anything? You do
Can
not
you
have.
okay? So you can represent the drop using 2D. Yeah, so like what I've been showing this whole time. The hypotenuse represents the drop.
And
Thank you
okay,
very much. I'm
let me
glad you
just
conceded to that my graph now, guys, thanks to the hypotenuse, literally shows flat Earth looking curved to these guys because of perspective. And no, orthographic view is not perspective based. Before anyone wants to strawman me again, it is just two-dimensional. And
you
all
see
these
you
differences
from my
now
chart
are
from
100%.
from my graph you're saying I can't observe perspective using orthographic 2D whatever, but you're trying to also show us the proof of perspective using 2D. So you are contradicting yourself.
Again, do you see a hypotenuse in reality as horizontal? The answer is no. The answer is no. So again, that orthographic view is not perspective. Me trying to explain it in perspective, yes, but it's not perspective. Does it show compression? Yes, because of the hypotenuse at a horizontal or the compression of these angles showing on the graph. Now, does that mean it's showing perspective? No, it doesn't. That means I'm trying to explain perspective in a two-dimensional manner for people like you to understand.
The fact that you are trying to use hypotenuse anyway, it just shows you don't even know what you're saying.
Again, stop saying I don't understand when I'm the one educating you on your own arguments.
The fact that you are a flat earther means you can't educate anybody.
Wow, that's a brilliant rebuttal. In fact, I'm a flat earther.
If you are really good at science, you can't be a flat earther. That is just a fact.
You know what that means you are then? If you're saying this dumb flat earther is so dumb.
You see,
if that is wiped the floor of you, I've literally wiped the floor of you. So what does that make you then? If I'm so dumb?
Oh, it doesn't make me anything. It just means you can't listen, and you misrepresent everything. Oh, okay. Let me give you a quote that perfectly fits you. They say, "Do not argue with a fool. He'll take you down to his level and beat you with experience." That is exactly who you are.
And I've got another one for you, Mark Twain. It's harder to convince a man he's been fooled than to fool him. Correct? So you've been fooled. So it's harder to convince you that you've been fooled than to show you.
This is exactly what baffles me with flat earthers. So somebody like you are a painter. You're not even a scientist. You are trying to think you are brighter than all scientists who are even from MIT.
You don't want to get into a science debate with me, mate. This isn't we weren't even talking science. If you struggle this much just with understanding perspective, you don't want to go into science.
I did not struggle. You are slow.
Would you count spectroscopy as science?
Pardon?
Would you count spectroscopy as science?
Spectroscopy. What is that? Is that like how light reflects?
The illuminations of light. Would you say spectroscopy is science?
Yeah, definitely. Somebody who's studying spectroscopy has to be a scientist.
Okay, I do spectroscopy. So even in your own conceding words, I'm then a scientist. And by the way, spectroscopy.
No. You're not a scientist because you're going against science.
I don't have a white lab coat, and I don't say we can have plasma burning in a vacuum for eternity. Yeah.
What always makes me baffle is people who don't even know anything about science, they think they are brighter than all scientists in the
Okay,
world.
what don't I
Another
understand
question,
about science? Be very specific. What I don't understand about science.
the fact that you guys don't believe in gravity, don't believe in very
Okay,
simple
okay,
things.
not just gravity. Gravity. Give me the hypothesis for gravity, please.
I already know all your talking points. You'll
Give
say
me the
gravity is fake.
hypothesis for gravity. Give me the hypothesis for gravity. You want to talk science? I'm gonna. Oh, this is gonna be fun. Give me the hypothesis for gravity, please.
Gravity is very simple. Like any body, a planet, whatever, it
That's not
bends time and
hypothesis.
space.
That's not hypothesis. I'm waiting for hypothesis for gravity.
That is gravity, bending of time
No
and space by a body.
hypothesis. I want your hypothesis for gravity. Scientific hypothesis.
That
You're
is
telling me I
the
don't
that is the
understand
scientific.
science.
Okay, okay,
You're telling
then
me I don't understand science, so I'm waiting.
okay,
Scientific
you know,
hypothesis.
because you are saying I don't know what is the hypothesis for gravity in science that science says. Because you're saying I don't know, what is it then?
You are the one making the positive claim. Burden of proof doesn't work. You claiming I don't understand science, but I'm asking you for simple things like for your claim. You say
I've
gravity.
already told you what gravity is.
You
Bending
say
of time and
gravity.
space by bodies.
What
So
is the
if you're saying if you're
hypothesis for gravity?
if you don't accept that, then what else can I say?
Exactly, Adam Meakin, spectroscopy is pseudoscience, and I do it every day. That's why I say it's not really science, but based on his own
You see,
understanding.
the fact that you are doing spectroscopy and you are a flat earther means it's not a serious science field.
Ooh, okay, so let's say someone like Dr. John D. He's got a PhD in spectroscopy. Now, because he's a flat earther, that means he doesn't have a PhD in spectroscopy. Is that what you're saying?
Any person who's a flat earther definitely shows me doesn't understand anything about
You know
science.
what bigotry means? Do you know what bigotry means?
I don't care what bigotry means. What I know is
Do you know what bigotry means? Do you know what bigotry means? It's quite disgusting, by the way.
I can just Google. It's not a big thing.
I think you should go and Google bigotry and look it up because you really exemplifying it 100% to the T. And you do know when you say, and you do know when you come and say, "Oh, you flat earthers, this and that." It's just because you don't have an argument. That's all.
I have already provided my argument, but you misrepresented it with hypotenuse, which I've not even placed it anywhere. So there's no point because you'll always misrepresent.
How did you get your angle data readings, your measurements for your graph without a hypotenuse?
That is what you always do. You always misrepresent what people say, then you come up with fake conclusion from the misrepresentation, and that is the problem.
You just literally made a statement that you don't have the hypotenuse, but you have data based on angles. So I'm asking you, based on your statement, how did you get that angle data without a hypotenuse? Because the hypotenuse is the constituent part for a damn angle.
Exactly, and I told you hypotenuse is important to get the angle, but once you get the angle, you use the angle and the distance. The hypotenuse is just to get the angle. Once you get the angle, you like look at these things you are drawing here, lines of hypotenuse. This is nothing.
Does that show a linear relationship when you take the hypotenuse and lie them over the horizontal?
No, that is not a linear.
Oh, so it's not showing a curve.
You see, you see what I did not plan. Okay, let me just tell you the truth. I did not understand. I did not predict. You won't even understand what I'm talking about between angle drop and distance. So if you are talking about hypotenuse, distance of hypotenuse, it just shows you you are so far. It just shows you are so far away. You don't even understand what you're doing.
Does distance change the angular drop?
Does
distance change angular drop?
It changes, yeah.
Does distance change the hypotenuse distance?
It does not matter because what matters is
it matters 100%. You know why it doesn't matter to you? It's because it throws your argument in the dustbin. That's why it doesn't matter to you.
You see, another problem is you do not even understand what hypotenuse is.
You know what? Instead of telling me I don't understand, go and show me how the hypotenuse is not relevant in an angle. Go and show me that.
It's relevant. But when you start drawing different lengths of hypotenuse, it shows you don't even understand what I'm trying to tell you. Because what you are plotting is angle the horizontal angle and hypotenuse, not the distance of the hypotenuse. But if you do not even understand that, there's no hope, man. There's really no hope, honestly.
I got one word for you guys. Bruh.
Actually, that is what flat earthers should say to themselves every night. Bruh.
So
Seriously.
this is all you had. So this is all you had to come do. Present that you don't understand perspective. Present that
No,
you
no,
don't
no.
understand refraction.
You
Present
see,
that you think
the fact that you are even
two-dimensional
talking about
is-
hypotenuse.
Listen here. You know why McToon is running away from me? Because he's got the same issue as you. Orthographic view is not taking perspective into account. Now you
Anyway,
are doing exactly the same shit. The only problem is you're not clever enough to know when to stop.
you see, you're talking about you are saying I can't use you can't use orthographic to represent perspective. Yet you are always using orthographic to represent perspectives.
I'm using orthographic view to try and explain it.
And what am I trying
show
to
me,
do?
okay, show me perspective on this graph that I put here. Show me perspective, please. Explain to me perspective on that.
Which graph?
My graph I've got up.
Oh,
Show me
this
where
one,
the perspective.
same one, or is it, has it changed, or is it the same one?
Same one. Show me where perspective is there.
There is no perspective there.
So conceding my point again, two-dimensional orthographic view is not perspective based. I can use it to try explain aspects of it in three-dimensional reality, aka like I did with the obtuse, the hypotenuse angle.
Let me say this. Let me say this.
Why you have your curve. Now, does this make two-dimensional orthographic view perspective? No, it's not. Perspective-based is a X, Y, and Z axis. Orthographic view is only a X and Y axis. 2 dimensions. You have to literally throw a third dimension away, and you can.
You are misrepresenting what I'm saying. I said there's no perspective in this because it goes against law of perspective. Because with increase in distance, there's constant drop. There's constant angle drop. And perspective says that increase in distance will have a continuously reduction. I don't even know if you understand.
All these droppings exactly linear based on this this graph by Polaris.
This graph, okay, I don't even know how to explain it even at this point.
And then let's go back to my previous one where I had the distances also compressing together with the vertical. That was me trying to explain the compression. But I decided, heck, you guys are always trying to strawman me and say, but put them on the distances exactly the same on the graph at the bottom. It will not work. Then you came and strawman saying why they're not all meeting at the same point. They're not supposed to meet at the same point because it's an apparent altitude angle. So if you measure something at 30 degrees, it's apparently 30. Is it physically there? Is it physically 30 degrees? No.
Yes, it should. On a flat earth, it should be physically.
From your position, it's an apparent. Just like I did with the flask. Did you see the flask when I did with McToon? By the way, guys, McToon still hasn't come back to me on that to tell me what the height of that flask is. Yeah, exactly. Same issue. That's why I take people like you and I throw your rubbish, your arguments in the rubbish. Because I'm not going to actually say something if I don't really understand it. A lot of the time, someone asks me something and I say, yes, I don't know. Because I'm honest.
No. You did not get my point. You didn't get my point.
Present me like you did with that other graph saying, oh, this guy sees everything at the same thing. No, by ignoring every little argument and words I said out of my mouth to you. So I don't understand how we should go on because you are literally being shown to be a liar on the stream many times now. And
which lie have I said? I've not said even a single lie.
What? I said like 10 minutes ago, you're lying.
Which lie?
How much did I bring up?
You see, the problem with you is you do not understand my point.
Did you or not did you say the sun has no perspective?
You see, this is exactly what you are misconstruing
Did
me.
you or did you not say the sun does
The
not have
sun,
perspective?
the sun is parallel, but those rays can appear to be
Did you
with
or did you not say the sun does not have perspective?
I said they come in parallel. It can be both. Sun is parallel.
Yes or no? Why can't you answer me? Did you say the sun does not have perspective?
The sun, when you see some of the rays, it can be perspective
Yes, you
based.
said it because you know you said it. Now you're trying to not answer me because you know you lied. That's a
I
lie.
know. I said I know where you're coming from. You said there's no parallel rays, and that is why I said even the sun
There
is
isn't.
parallel rays.
There's
That is what
no
I said.
parallel rays. No spherical light emits parallel rays.
And
You
I asked you.
demonstrate this no matter the distance you place it at, because of inverse square law of light, totally debunks that argument, and it shows you guys don't actually understand any arguments you bring forth.
So what
Hence
you are
why you
trying
guys
to say,
the word refraction in the first
what you are
instance.
what basically you are trying to say is you are brighter than all the scientists in the world, because every scientist
Where did I
knows,
say anything about a scientist?
because science knows that sun rays comes to Earth parallel.
We don't really have time because the power is going off in 15 minutes, but I want to know, where did I say anything about scientists?
You are saying there's no parallel rays, and I told you
There
sun comes.
It's not scientists. There is no spherical object that emits light that gives parallel light. It's
Is it
a
possible?
divergent shape.
Let me just Google for you.
It's a divergent shape.
Let me
Do you know?
just let me just Google for you.
Okay, Google for me.
Let
Because
me just
you literally don't understand divergencies. What's a shape? This is sad. But yeah, guys, the power is going off in 13 minutes. So I just want to say we're probably only going to go on another maybe 5-6 minutes with this guy. Then I'm going to have to close off, unfortunately. I'm actually getting a headache. The poll says 146 votes. Polaris is for FE. Yes, 51%. No, 45%, and not sure, 5%. For all those that say not sure, maybe you should watch from the beginning, and then you'll see it's literally for flat Earth. And all that says no, maybe like MediaDon. Thank you for coming on again. You might want to re-look at everything, because you've literally shown the globe has nothing but excuses and
Oh, actually, what you have shown me is flat earthers. They are experts.
Charles Pocket.
Experts.
Yes, we do have
Experts
data.
at
What's the
misrepresenting. Expert misrepresenters. They will always misrepresent everything, and they will use their misrepresentation to come up with a fake conclusion. And that is why this is the problem with most flat earthers. Instead of just sitting and trying to understand your point, they will come up with a counterpoint, which is a misrepresentation of your point.
I understand your point. That's why I'm ripping it to shreds. That's how it works.
You are not ripping anything to shred because you are not understanding my point.
Okay. Hypotenuse doesn't matter in angles. That's your argument. No, you
No,
don't
no,
understand.
no, no,
That's your argument.
no,
No,
no, no.
you're a flat earther, so therefore you don't understand. That's your argument.
I say hypotenuse.
More
You see,
intelligent than
you are even misrepresenting my points. I said
no, that's
this,
stating facts.
the length. I said the length of the hypotenuse does not matter. What matters is the angle and the horizontal distance. That is what I said. But you are now trying to tell me that I said the hypotenuse distance does not represent anything, and that's why I did not even. You see, exactly.
And distance changes the angle. Change the hypotenuse in a triangle. What happens?
The distance, the hypotenuse distance does not change the angle.
Change our okay. Go quickly to a calculator on Google for us all. Go and do
angle.
Change the hypotenuse distance squeeze and tell me that does not change the angle.
It does not change that because, for example, you can have an angle of 30 degrees and have it even 1,000. You can have a hypotenuse that is 30,000 kilometers. You can even have a hypotenuse that is 20 centimeters, but the angle is the same. What matters is the angle and the horizontal distance, and that because you do not understand that, there's no way I can
You do not
explain to you my
understand.
point.
No, there's no such thing as I don't understand. It's you simply
You do not.
don't want to
You
accept
just do. You do
understand.
not understand. That is exactly what you do not. You do not understand. That is the
What
truth. You do not
don't I
understand.
understand exactly? What do I not
Pardon?
understand exactly? What do I not understand?
What you do not understand with what you do not understand is we are using angle angle and the horizontal distance. Then you are using hypotenuse, which doesn't
Okay,
matter even
on
when you
screen.
calculate.
Okay, on screen I got a hypotenuse calculator. The hypotenuse is sitting at 3,905.12.
Mhm.
Let's change this. Obviously, now this is for the hypotenuse, so let's just change the horizontal, maybe to 4,000.
It
Oh, did
will
the
it will
hypotenuse change?
it will
So,
change.
okay, so now does that change the angle?
I don't even know. Are you even being serious at this point?
Does it
Honestly,
change the angle when you change the hypotenuse distance?
the angle is an angle. You can have even 30 centimeter and a half.
Does it change the angle when you change the hypotenuse
when
distance?
when when you see, this is the thing, when you have the same angle and the same,
Why can't you answer me? Does it change the angle when you change the hypotenuse distance?
you have to also change the horizontal
Yes,
distance.
it does. I'll answer for him. Yes, it does.
Obviously it does. Did I say it
So
doesn't?
therefore, your argument is mute,
It
and
is
you just
not mute.
conceded.
It is not mute. What you are not getting is, we are not talking about hypotenuse, we are talking about angles and horizontal distance. That is what you are plotting.
Hypotenuse, when you talk about an angle, you are talking about a hypotenuse. It's
you,
like
you,
saying I wear shoes without shoes.
you need a hypotenuse to get an angle, but the length of the
Oh,
hypotenuse does not
again.
matter.
Okay, guys, unfortunately, I'm going to have to close off here. Thank you, MediaDon, for coming. Maybe we can do this another time, and maybe you can get help next time because you definitely need it.
I don't need
Sorry.
help. You guys need help. Flat others need help. I don't need any help. You guys need help, actually, and I'm serious.
Tim Kership, censorship, not at all. He literally has been given his first in the beginning to do his presentation. He did it, and all he did the whole stream was, nah, you don't understand, conceding everything, double speaking, contradicting himself, and
I did
lying.
not double speak. I did not
So,
contradict myself.
yeah, that's
You
exactly
are the one who misrepresented everything I said. You are the one who did not understand my points.
I
Then
got homework.
you use my misrepresentation to come up with your own fake conclusions.
Then I got homework for you. Go through the stream and show where the misrepresentations were. Okay?
There is no misrepresentation from
Yeah.
myself. You are the one who misrepresented all my
Go
arguments.
through the stream, create a video on where I misrepresented anything. Go ahead. And then explain how I misrepresented it, please. This should be good.
Anyway, let me just say, but thanks for having me, man. Because at least this is honestly, I'm not even sure at this point. Like, are you open-minded, or you are so closed-minded that you don't even want to hear counter arguments? But anyway, but what I'm thinking is, as the fact that you're allowing people like me on your stream, it means at least you are at least slightly open-minded, which is a good thing. And thank you for giving me this opportunity, even though I did not. I don't know if I did not manage to explain myself well or what, but I guess I can say it is what it is, man.
Explained yourself perfectly. The problem is every argument you brought up, you were proving flat. That's the issue.
No, it doesn't prove flat. There's no argument I proved flat.
I explained every way why it was flat. But thank you again for coming here. We can maybe do this again. Maybe next time you can get some help.
Okay, but yeah, thanks a lot for having me. I know you don't have. I don't know. I know you don't have to have us globers here, so it's good to have at least counter arguments, and
Yeah, no, I really appreciate you coming
maybe
on.
one day, God willing, you guys will see the light.
Remember, we were Globers. We did see the light.
No, you were globers until you got into the cult.
You were born in a cult. You're born to be indoctrinated to the globe.
There's no way you can say all science is a cult. There's no way.
Science is a cult. It's called scientism.
No. Science is science. Science is based on mathematics, is based on what you observe. That is not a cult.
Science is only a method.
Look,
Science is
science
only
does
a method. Scientism is
look,
the cult. Science
look.
is a method.
Science does not matter whether you are Chinese, whether you are French. Science is science. It is not
It's
a
a
cult.
method. It's just a method.
There is no cult called science, but there is a cult called flat earth. And can I just explain to you one more thing before?
Oh, really? My power's going to go off now. Sorry, mate.
Okay, no problem.
But yeah, thanks for coming. We can maybe set up another time again. Like I said, then
Okay,
maybe
no
you can
problem.
get
If
someone
you
from
allow
our
me, I
people.
want to deny the opportunity.
Sharp.
And
Thank you
I'm
very
also very thankful for at least giving me a chance to express my different opinions. And if this didn't work, I don't know if you guys will be forever flat earthers.
Yeah, thanks. Sorry to be blunt, but based on the evidence, I'm definitely going to remain flat earth.
No problem. I understand. You didn't understand my point, so I totally get it.
No, I do understand. That's why I ripped it apart. I mean, we
No.
didn't even get
You did not rip anything apart.
We literally didn't even get through perspective properly to get into refraction. Then you would have even failed even more, Mr.
There's no hopes. Basically, what I'll just say is no hope. If you are not even on the same page, when you are talking about hypotenuse and I'm talking about distance, horizontal distance and angle, and you're talking and you're plotting hypotenuse distance, it shows you are so far away from where I am that there's no even point in arguing.
Okay, yeah. Thank you for coming again. Really appreciate it. I'm going to have to close off now.
Okay, no problem.
Yeah. Thank you. Yeah, till next time.
Okay, till next time.
Shot, mate. Bye.
Okay, bye.
Okay, guys, that was Don. Wow. I don't know. I was actually trying so hard not to be rude and stuff, but it just got to a point where this guy literally doesn't understand anything he's coming out of his own mouth. But yeah, it was funny. So thank you guys for coming. I'm sorry I have to cut it off now because the power is going off at 11. It was awesome. Thank you all for the super chats. Really appreciate the super chats. Thank you, everybody. Thank you, Don, again for coming. No hard feelings. I still think you're a great guy, everything. Not the brightest guy in the tool shed, the sharpest tool in the shed. Yes, I would like him to actually go and find me a spherical light that emits parallel rays. And then I would just say thank you to everybody coming. Yeah, you guys are all awesome. I think it was a great stream. And we'll see you guys all tomorrow night again. Many blessings, and may the pressure be with you. Bye-bye.